Hello, welcome to the validation world. If you come into this, that means you are interested to know about mechanical vibration test in automotive company. So I want to make sure you understand the big picture of what does mechanical vibration test, what's the use of this, how do we test, what equipment we use, and then after we complete the test, what's our judgment of our design. So, with that, let's start with the goal. The goal of mechanical vibration is to make sure that the design is mechanically tolerant to the real world. So, this is typically what they do is just to simulate what the vehicle experienced in the real world. And how do we test it? And when you see, like, if you see here, this vehicle is called X back and forth, and then Y left and right, and then Z is up and down. So those are kind of terminology you use during mechanical vibration. Most of the time you have to test it in 3 axes. If you have a mass, it's a multi-axis vibration, you use that, but a lot of Tesla they don't have that one, so you do X, Y, Z separately. And then when you do, at least let's talk about the parameters. The parameters, first of all, you confirm you tested in 3 axes, and then how many hours is equivalent to the lifetime of the component. So you have to see, it can be a week, it can be like 100 hours, it can be 300 hours. It's depend on where your part is located in the vehicle. Some of they don't expose a lot of the lot of exposure, and some of them are sitting on the chassis, and then they experience a lot of an up down. And check what's the frequency, and then you have to make sure the frequency between 2 to 100 to 2000 300 is depend on the vehicle. And then check the maximum and the minimum temperature. So even if most of the time the vehicle experiences room temperature, but we do an acceleration is time compressor. We want to compress a 10-year life into maybe 2 weeks or 3 weeks duration of time. So that's called compressor. So you have to make sure the extreme temperatures. So what are the equipments we use when we perform this? The equipment, as you can see, we use this is a mechanical vibration machine or a shaker, and then there's a software associated that go with it, and use accelerometer and thermal chamber. Those thermal chambers, and so you experience a hot and low cold temperature, minimum frequency, high frequency, and then all those G levels supposed to be implemented on this machine. And then before you start the test, you have to like a pre-test. Make sure, because this is kind of expensive test and then time consuming, so don't ruin your test. Make your precondition before you start this test. So one of the things, do a science sweep to make sure that your fixture and your machine is okay, that the data that gives you is validated, very good data. So to make sure that run science sweep, it's most indirectly it's a fixture or it's a machine validation. So you validate the machine first, because a shaker can develop, armature can be cracked and something can be loose, so that can give you a false information, so which will cause you into a different design. So, and then during science sweep, there should not be a resonance frequency. There is no resonance supposed to be happening. So that's one of the things. And then, so with that, you can do the test. But where did the profile come from? So let's talk about the profile. So most of the time, like engine is very high aggressive mechanical vibration profile. But for your components, depend on where in the vehicle, if it's somewhere it can be less or high. So based on that one, most of the time they drive the vehicle and then they take the data, they tune it, and then they take the acceleration part of all those, uh, enter into profile, they amplify it, they compress it, and then they accelerate it, and then they feed it to the machine, and the machine will be based on whatever you feed in. So you program it. But here shows a little bit of about how do you the profile. For example, if you see the green is where you expect, and then the blue is like what's your response. So that's like ideal, but the blue is just what the response, because it's, and then you have another tolerance. So yellow is a tolerance. So if that happens, so you are you expected it plus or minus like 3 dB, 2 dB, but if you are over that, that means gotta be cautious that okay, it shouldn't be past that tolerance. And then, but if your response hits the red, that means stop, the machine will stop. That means there's dramatically something's broken out of your equipment, so better to stop it before you move forward. So you stop it and you analyze everything. So that's for abort. So with that, you can do your mechanical vibration to make sure your mechanical structure of your sample is getting ready for life. After you've done all the mechanical vibration tests, what you do is you have to open up. You have to disassemble everything and look out for structural fatigue, broken mountain, any adhesive, deformation, bent, loose fastener, everything. You do both the structural and the PCB board, the cell tab, cell, if you are testing a battery, interconnect, the bus bar, the cell, the module, you see everything that comes. So because most of the time the batteries, they are not serviceable, most of the parts. So to make sure that on the design level, when you tested, like validations, the eyes and ears of the design team, so to make sure that gives them the right information, tested properly, and then with that you can save money for the company, save warranty, and you can save the development time, and you can save the life of the design team. With that, that's all about mechanical vibration for today. I'll see you on a different topic, and thank you for coming in. Have a good day.